Hello, my name is Angus Connolly and I'm the product manager for our Flexcom software. In this tutorial I'm going to show you how to set up some simulations in Flexcom Wave and how to extract results via post-processing. If you've been following the tutorial series so far, you'll have noticed that we're following a model called Floating Dual Body Point Absorber, which is shown on screen at the moment. If this is your first video, then you can bring up this project by going to Help, Example Projects, Floating Dual Body Point Absorber. So now that the point absorber, the device, has been defined in Flexcom Wave, and the Wave environment, in this case it's called Eureka California, has also been defined or extracted, downloaded from the Exceedance Finance product, it's now time to go ahead and perform some simulations. We have all the information we need. So I'll maybe right click, add a new simulation component, because it's called New Simulation. I'll bring that up on screen here. So the first thing to know is that in the simulation component you need to select a wave energy device and the wave environment. These have been pre-selected by the program for you because this is a very simple project which doesn't have that many components here. It's only got one device and one environment, so they're automatically pre-selected. If you had more devices, then they would be available from the drop-down list here. The next thing is to start typing in some solution time parameters. Normally you might want to run these simulations for 30 minutes or maybe even 60 minutes depending on your preference. Let's say 30 minutes, let's say 1800 seconds, a time step maybe of 0.1 or 0.2 seconds, and a ramp time perhaps of let's say 100 seconds. Further down here you can see the wave scatter diagram, which is identical to the Eureka California site which we've imported. So if I was to press the run button now, it would run a time domain simulation for each unique combination of HS and TE in the grid. If I wanted to, I could also, as discussed in previous presentations, I can group similar C states together, create a block, and then define or nominate one C state as being representative for that block. In this case, Flexcom only runs the reference C states that you've defined, and for all other cells in the grid it extrapolates or estimates results based on the answers for the reference C states. That's covered in another tutorial, which was the previous tutorial on the wave energy resource, which was covered in the previous tutorial. You'll have seen how I set that up, but it's quite straightforward. You just literally create a block and then nominate one of the C states which might be representative of all of the wave combinations within that block. So I'm just going to clear those now. So the next step is actually proceed and run the simulation. So you press the run button here. I won't do that now because running all these different combinations of HS and TE would be quite time consuming, so I'll just go straight to a simulation which I prepared earlier, just for efficiency in terms of visualization. There are two parameters here, the simulation parameters which we just looked at, and then the next one is the simulation results, which are obviously available when all the simulations are completed. The main output from Flexcom Wave is a power matrix, which you can see in the center of the screen now. So this, for all the combinations of significant wave height and wave period, we have a electrical power matrix in kilowatt for the device. And you can see that this is color coded so that the more stronger colors indicate regions of larger power. This power matrix, which should be familiar to any wave energy developer, is then combined with the wave energy scatter diagram, which we see on the previous screen, multiplying the wave energy probabilities by the power output for each combination. We get an annual energy production in megawatt hours, which you see on the right hand side of the screen there. At that point you can export that data, which is the critical data, back to the Exceedance product, where a financial appraisal, the commercial feasibility of the device in this particular geographical location can be assessed. If you're to do that, you select File. I'll just go through that once more time. File, Export to Exceedance Cloud, and then you select the location. I've only got one location here, which is Eureka, California, and then I can select the simulation which I want to export. So press the Export button. That will be sent to the Exceedance Finance database, and you can from within that product then perform your financial assessment using the power matrix that's been created by Flexcom Wave. I'll just park that for now, because that will be covered in another tutorial. Then just to look at some other outputs that are available in Flexcom Wave. There's a high-level summary which allows you to view plots and the spreadsheet for the entire load case matrix. Let's just have a quick look at that. So for example, let's just look at the average electrical power. This is basically the power matrix, just presented in, rather than presenting it in a table, it's presenting it in a 3D plot. So you can see that electrical power in kilowatts is on the vertical axis, with HS and TE on the horizontal axis. That's a full 3D plot, so you can pan and zoom and move around within it. You can also just zoom in. You can turn on some tooltips to pick out exact values for any. So for example, for this combination of HS of 4.75 meters, TE 9.5 seconds, the average electrical power for that seed state is 286 kilowatts. So it's just reached the maximum, or the capped power for the device. Manipulating the plots, this is a Flexcom Wave's plotting module. We'll cover that in a separate tutorial, but basically all of these commands on the top bar here allow you to move and have various options for viewing the plot itself. I'll just close that down now. I'll also open up the summary spreadsheet in Excel, which summarizes all of the data. I just showed one plot there, but there are many different plots that you can extract from Flexcom Wave. It's not just electrical power, which can be predicted from the PTO damper element. Because Flexcom Wave is a structural solver, you can get any kind of information like tensions or bending moments, and for structural members, or for example mooring line tensions. And this is automatically summarized for you in this spreadsheet here. So if I scroll right down to the bottom of that spreadsheet, for example, if I look at the tension, the fair lead tension, so at the top of the first mooring line, the maximum tension that's been reached for this particular load case matrix is 783 kilonewtons, and that happens for C-state combination, which is HS 1.75 meters and a wave energy period of 5.5 seconds. So there's a lot of information there available at your fingertips, including not only electrical power, but also structural information like stresses and strains in the mooring lines and so on. I'll just close that spreadsheet without saving. So that's the high-level summary, which presents results right across all of the different sea states. And if you select maybe one particular sea state here, you can actually view individual time history plots for an individual time domain simulation. Let's just bring up the plotting module. So what we're showing on screen here is electrical power as a function of time for the PTO. You might notice that on the lower screen here, I've just run that for 360 seconds, which is very short. Normally I'd run it for 30 minutes simulation, or perhaps 60 minutes. In fact, I think 3 hours would be recommended duration in oil and gas industry for statistical certainty associated with a random process, simulating a random wave spectrum in the time domain. This just allows you a little bit more detail to see what's going on as a function of time, rather than just looking at the average total average power across all the simulation time for that particular combination of HS and TE. You can also look at mooring tensions at the fair leads and the anchor points and so on. I'll just close the plotting module now and return here to, let's have a quick look at the structural animation. I might just make this a little bigger for you once the animation loads. Make the screen a little bigger so you can see it better there. So this is an actual structural animation, so we can actually play it back. We'll just zoom in a little bit so you can see the device in more detail. You can actually view the structural response in real time. I'll just speed it up a little bit so you can exaggerate the motions. Hopefully you can see the device moving up and down slowly there in response to wave loading. Push on just pause and move on to the middle of the simulation just to get past the initial ramp time where the wave loading is now fully applied. And you can hopefully see that the upper float is moving up and down on the spar buoy, and the relative movement obviously drives the power takeoff mechanism. So there's lots of different options here in this model view. You can look at different elevations, you can split screens, so on. Look at some predefined views. We'll just look at a side elevation here, look at maybe the other elevation in this view, so you can look at with the waves, you know, coming from the side or coming head on as you look at it. So you can do lots of stuff with this model view. You can even display stresses and strains on screen, so you can look at, you can color contour, say, effective tension in mooring lines. Maybe a little bit difficult to see there, but you can color code stresses and strains in the model view itself. The model view is covered, the operation of this model view, which has got lots of different options, is covered in a different tutorial. So I'll just let you know it's there, and the tutorial is available for you to explore all these options. I'll just close the model view again, and that really covers all of the running simulations in Flexcom Wave and the extraction of results in terms of post-processing. So Flexcom Wave makes it quite easy for you. It presents the results which you're interested in, or likely to be interested in terms of power matrix, annual energy production, mooring line tensions, and so on. If you wanted to delve into even more detail, you could actually migrate from a Flexcom Wave into the mainstream Flexcom product, which would give you even more options. So you could start looking at bending moments or bending stresses in structural members, which would be more of a customized post-processing option that you would need to do in the mainstream Flexcom product itself. And I'll probably cover that in another tutorial subsequently, showing you how you can actually migrate from Flexcom Wave into the mainstream Flexcom if you want to get actual more power and more insight into structural results. But for the moment, I think that concludes the overview of running simulations and extracting results from Flexcom Wave. So I hope you can join me for a future tutorial.